Welcome to SOLIDWORKS for the Engineering Design Process, Lesson 5, Section 3, Part 2. In this video, you'll learn how to create a custom material in SOLIDWORKS, apply it to your part, and then use Simulation Express to conduct stress analysis. You'll then modify the part by removing material from it to make it lighter and more sustainable. You'll conduct stress analysis once more and compare the results. For this video, the windmill base will be used. Open it now. Rather than using a material from the SOLIDWORKS material database, you'll create a new material and apply it to this part. Currently, alloy is selected as the material for this base. Right-click it and select Edit Material. This opens the Material dialog box where you can select the material and its properties. To create a new material, right-click in the left pane and select New Library. Type the name of your material database, My Materials for example, and click Save. Now right-click My Materials and select New Category. Call this category Metals. If you want to create a material similar to alloy steel, for example, you can reuse it and change some of the properties. Expand SOLIDWORKS Materials, Steel, right-click Alloy Steel, and click Copy. Now scroll down to the My Materials library, right-click your new category, and select Paste. Rename it to Steel 1, for example. You can now modify this material's properties. Under the Properties tab, you can modify any of these characteristics. For elastic modulus, change it to 1.8 times 10 to the power of 11. Change the Poisson's ratio to 0.3. The mass density to 7,500, and the yield strength to 5 times 10 to the power of 8. Apply, and then close. As you can see on the Feature Manager design tree, the new material has been applied to the part. Now that your material has been configured, you're ready to use Simulation Express to analyze the performance of this part under stress. Under the Evaluate tab, click Simulation Express Analysis Wizard. Click Options and select SI as the system of units, then click OK. Click Next to move on to the fixtures. Click Add a Fixture, and then select the inner round surface of the 3 mounting holes. Click the green check mark and click Next. Click Add a Force and select the top face of the base, since this is where the weight of the windmill and all the stress is applied. Change the magnitude of the force to 1,000 newtons. Click the green check mark and click Next. Ensure that your custom material is selected here, and click Next. If you want to change the mesh density, click Change Settings. Keep it at the default settings for now, and click Run Simulation. After Simulation Express is done loading, the animation of the part's response to the loads will begin. Click Yes, Continue to view the results. The minimum factor of safety is approximately 1.6. Since it's greater than 1, the part is not expected to fail under a 1,000 Newton load. Change this field to 6 to see which regions have a factor of safety greater than 6. These blue regions represent the regions that are safe, meaning they have a factor of safety greater than 6. The red regions have a factor of safety less than 6. The legs of the base are also blue, so if you modified them by removing some material, the part will still remain safe. The reason material is being removed from the part is to make the part more cost-effective. Another reason for trying to use less material is to reduce the impact this part has on the environment. You'll be using the extruded cut feature to cut a triangle-shaped wedge out of each leg. This will maintain structural integrity and safety of the part while making it lighter and cheaper. Exit the Simulation Express task pane. Click Yes to save the simulation data so that you can rerun the study once the modifications are made. Under the Features tab, click Extruded Cut and then select the face of the leg. The Sketch toolbar will automatically appear. Click Offset Entities and then click the face of the leg again. Set the offset distance of 7 mm and select Reverse. Click the green check mark to apply the offset and then click Exit Sketch. Under Direction 1, select Link to Thickness and then click the green check mark to apply the cut. Repeat this procedure for the remaining two legs. Now that the modifications to the base are complete, rerun the study to analyze the modified base. Open Simulation Express, click Next to continue from your previous analysis, skip to Step 4, and rerun the study after Simulation Express is done loading. You can see that the base seems to be flexing more now that the legs are weaker. Click Yes, Continue to view the results. The factor of safety is now approximately 1.4, which is 12% less than before. This means the part is weakened slightly, but is still safe to use. This is an example of Step 8 of the engineering design process, redesign. In the first iteration, you used more material and determined that the part is very safe. In the next iteration of the design process, you removed some material to make the part lighter, cheaper, and better for the environment, while still maintaining a factor of safety above 1. An e-drawing allows you to share the simulation analysis information easily. The e-drawing will contain the equivalent stress plot, displacement plot, as well as information about the deformation and factor of safety. To generate an e-drawing, click Done Viewing Results and then click Generate e-drawings file. Select the location and the name of the e-drawing file and click Save. The e-drawings viewer opens and displays the equivalent stress plot. As mentioned earlier, you can view the displacement, deformation, and factor of safety plots. In this video, you learned how to create a new material in SOLIDWORKS, apply it to the windmill base, and then use Simulation Express to conduct stress analysis. You then removed some of the material from the legs of the base and conducted the analysis again. You also learned how to generate an eDrawings report to share your analysis results more easily.